Okay, let's jump right in. Did you know, and this is something that always gets me, that everything we can actually see and touch, measure, stars, planets, us, it's less than 5% of the whole universe.
Yeah, it's incredibly humbling, isn't it? All that stuff we see out there, all the astronomy pictures, just a tiny, tiny slice.
Absolutely mind-boggling.
Mhm.
So that's really what we're digging into today, this massive 95% that we just we don't really get. It's mostly this stuff called dark matter and something else called dark energy.
Right, and we've been looking at a really helpful piece from NASA Space Place to sort of guide us through this cosmic puzzle. It lays it out pretty clearly.
Yeah, it does. So our mission here is basically to unpack what that source tells us. How do scientists even know this invisible stuff is there? What's it doing? And maybe most importantly, why does it matter so much for, well, understanding everything? It's kind of like looking at the universe and asking, okay, what's really making this tick?
Exactly. It's like cosmic detective work, really. You're looking for clues left by things you can't see to figure out the whole story.
So let's start with just how much of this mystery stuff is out there. The source gives the proportions, and they're pretty stark.
Oh, they are, yeah. So according to the data NASA presents, dark matter, this invisible mass makes up about 27% of the universe's total budget of mass and energy.
Okay, 27%, a little over a quarter, and the rest of that huge 95% chunk.
That's mostly dark energy, and that's even bigger, roughly 68%.
Wow. Okay, so 27% dark matter, 68% dark energy. Add those up, and yeah, you get 95%, which leaves everything we know and understand, galaxies, stars, planets, you crammed into that little 5% left over.
That's the picture our current observations paint. It really does put things in perspective.
Yeah.
I mean, how much of reality is just fundamentally different from our everyday experience? The source talks about the early universe, right after things started clumping together.
Right after the Big Bang. Gravity starts pulling matter together, forming the first stars, the first galaxies.
Yes, exactly. And that's actually where the dark matter mystery really started to emerge. Astronomers were looking at galaxies, clusters of galaxies, and they noticed something odd about how they were moving, specifically how they were spinning.
This is the part I found really cool, how they realized galaxies were spinning way too fast.
Precisely. If you just added up all the mass, you could see the stars, the gas, the dust, and calculated the gravity from that. Well, the outer edges of these spinning galaxies should have been flying off into space. The source kind of compares it to a merry-go-round spinning too fast.
Yeah, you'd get flung off if you were on the edge, unless there was something else holding you on.
Exactly. But the galaxies weren't flying apart. So the implication was there must be a lot more mass in and around these galaxies than we could account for with visible stuff. Mass creating extra gravity. And that unseen mass is what we now call dark matter.
So it's like this invisible scaffolding providing the extra gravitational pull needed to hold these fast-spinning galaxies and even whole clusters of galaxies together.
That's the core idea. It acts like a sort of cosmic glue. And it seems to make up the bulk of the mass in most galaxies.
And the really weird part is we don't see it interacting with light, right? It doesn't glow, it doesn't block light, it doesn't reflect it. We only know it's there from its gravity.
That's the fundamental challenge, yes. We can't point a telescope and see dark matter. But we see its gravitational influence everywhere, just like, we feel Earth's gravity holding us down even though we don't see gravity itself. Dark matter's gravity shapes how stars and galaxies move. And that observation, that stars way out in a galaxy's suburbs orbit just as fast as stars closer in. That's really strong evidence. Visible matter alone just can't explain that.
Okay, so dark matter is the invisible glue, about 27%, holding cosmic structures together. What about the other big unknown, dark energy, the 68% chunk? What's its story?
Dark energy. That's tied to a different observation, maybe even more perplexing. It's about how the universe as a whole is expanding.
Right, we know the universe started with the Big Bang and has been expanding ever since. But the source says it's not just expanding, it's speeding up.
Precisely. That was a huge surprise. For decades, astronomers expected the expansion to be slowing down.
Yeah.
Because all the gravity from all the matter, both the normal stuff and the dark matter, should be pulling everything back together, acting like a brake.
Makes sense.
But then, in the late 1990s, observations of distant supernovae, exploding stars, showed the opposite. The expansion isn't slowing down, it's actually accelerating. It's getting faster over time.
So something is pushing space-time itself apart, overcoming all that gravity on the very largest scales.
And that something, that mysterious outward push, is what physicists have labeled dark energy. Honestly, we know even less about it than dark matter. We don't really know what it is fundamentally, but we see its
Yeah.
effect, this accelerating expansion. It almost seems to be woven into the fabric of space itself.
Okay, let me try and get this straight. You've got dark matter making up maybe 27%, acting gravitationally, holding galaxies together like glue. Then you've got dark energy, a much bigger chunk, like 68%, doing the opposite, pushing the universe apart, accelerating the expansion.
That's a picture, yeah.
And these two things, which we basically don't understand at all, make up 95% of everything that exists.
That's the current standard model of cosmology. Based on all the observations we have, it really does leave just that little 5% sliver for, atoms, light, everything we are familiar with.
It really makes you think, doesn't it? Our entire understanding of physics might just be describing that tiny 5%. So, okay, if we can't see dark matter, can't directly poke dark energy, how do scientists actually study them beyond just, noticing galaxies spin too fast or the universe expanding quicker?
Well, the source points out they have to be clever and rely on indirect methods. It's all about observing the effects these things have on the stuff we can see. And one really powerful tool they use is something called gravitational lensing.
Gravitational lensing. Okay, sounds like gravity bending light.
That's exactly it. Einstein's theory of general relativity predicted this, that mass warps space-time around it. And light, as it travels through space, follows these warps or curves. So if you have a really massive object in the foreground, like a big galaxy cluster.
Which has lots of dark matter in it, presumably.
Exactly. That cluster, with all its mass, both visible and dark, acts like a giant cosmic magnifying glass, or maybe more like a distorted lens. Light coming from a much more distant galaxy traveling towards us gets bent as it passes by or through that foreground cluster.
So the light from the distant galaxy gets distorted, like looking through the bottom of a wine glass, maybe. You might see stretched images or multiple images of the same galaxy.
Precisely that. You can see arcs, streaks, multiple copies of the background galaxies. And the key thing is, the amount of bending, the degree of distortion, tells you directly how much total mass is in that foreground lens cluster, including all the dark matter that you can't see. By studying these distortions across the sky for millions of galaxies, scientists can actually map out where the dark matter is and how much of it there is.
Wow, that's ingenious. Using gravity itself as a scale to weigh the invisible universe. The source mentioned telescopes are obviously crucial for this.
Oh, absolutely. Telescopes like the Hubble Space Telescope have been pioneers in capturing these faint, distorted images, making these incredibly precise measurements.
And it sounds like there are even more powerful instruments coming online soon or being planned.
That's right. The source specifically mentions NASA's upcoming Nancy Grace Roman Space Telescope. It's designed with these big cosmic mysteries very much in mind.
Roman's going to map, what, hundreds of millions of galaxies? Look at their shapes, their distances.
Exactly. It will conduct huge surveys, looking at both gravitational lensing effects on a massive scale and also tracking the expansion history of the universe with incredible precision by measuring distances to countless galaxies. So the data from Roman should give us really crucial new clues about the nature of both dark matter and dark energy. It's a very exciting time for cosmology.
Okay, so let's try and wrap up what the source material really laid out for us. Basically, the universe is, well, mostly unknown territory. About 27% seems to be this dark matter, this invisible gravitational glue holding things like galaxies together. We know it's there because of how it pulls on the stuff we can see.
Right, inferred through gravity.
And then there's the even bigger piece, about 68%, this dark energy, which is causing the universe's expansion to speed up, pushing everything apart. And its nature is even more mysterious.
Still a huge question mark.
And scientists are tackling this not by seeing it directly, but indirectly, using tools like gravitational lensing, mapping how light bends around massive objects, and employing incredibly powerful telescopes, like Hubble now and Roman in the future, to gather that subtle evidence.
It really does kind of flip your whole perspective, doesn't it? I mean, everything we normally think of as the universe, all the stars and galaxies we see, it's just this small froth floating on a deep, invisible ocean of dark matter, all while being pushed apart by dark energy. It strongly suggests there are fundamental laws or components of reality we just haven't grasped yet.
Absolutely. It feels like we're standing on the shore, looking out at this vast ocean, knowing most of it is hidden beneath the surface. We're just starting to figure out how to probe those depths.
Which leads to a really fascinating thought to leave you with, doesn't it? You know, given that 95% of the universe is this profound mystery, what incredible new physics might be waiting for us as we learn more about dark matter and dark energy? Could there be new forces, new particles? What else is lurking out there in the cosmic darkness? waiting to completely rewrite our understanding of everything.